In our second example for writing an absolute value function, what we want to do is we want to take a look at the graph on the left, and we want to be able to identify the a, the h, and the k from that graph. Now, the h and the k always comes from that vertex right here. Now this vertex is located at -2, 0. So that means that the value for h is going to be -2 and the value for k is going to be 0. Now to identify the a value, remember we want to start at our vertex and we always want to travel to the right. So start moving to the right along this right here, and we want to find another point on the graph that this ray passes through, and it looks like we've got one right here at 2, 3. So now what we're going to do is we're going to look for the slope or the rate of change between those 2 points. So start at your vertex and travel to the new point. So we're going to go up 3 and we're going to travel over 4. So that means that our a value is going to be 3/4. Now once you have the a, the h, and the k, all that needs to happen is we just need to substitute in those 3 values into our standard equation for an absolute value function. So we're going to have f of x, or you could make this g of x, h of x, m of x, does not matter. In for the a value, we're going to substitute in that 3/4. Then we're going to draw the absolute value bar. Then we're going to have x. Now we want to be careful because if we were going to take this h equals -2 and substitute it in where there's already a subtraction sign, what's going to end up happening is that subtraction is going to turn into an addition because we would really have minus a negative, which would change to adding the opposite, which would become plus positive. So we're really going to end up with x plus 2. And then since there is no k value, or we have a k value of 0, we could substitute in the 0 and put plus 0 at the end, or we could just leave our function as is. So the function for the graph on the left is f of x equals 3/4 times the absolute value of x plus 2.